Okay, in this video we're going to talk about nonlinear inequalities. And these are inequalities that look like nonlinear equations, meaning they have x's have exponents on them. And they represent regions on the number line, so maybe an interval, maybe a couple of intervals. So our goal today is to kind of discover how to solve these inequalities and what these regions look like. So we'll go ahead and just jump into this first example. Because I think it's going to be easier for me to just show you the process rather than explain it all up front. So our goal, in this case, I have a quadratic nonlinear inequality, right? It's nonlinear because it's quadratic. And I have x squared plus 2x is less than 8. So my options for solving a quadratic equation are factor, complete the square, or use the quadratic formula. And recall that we're trying to find the region that this corresponds to. So I'm going to go ahead and factor. This is what you should be doing, and we'll see why here in a second. So my goal is to get this inequality into a form that I can factor. So I'll subtract 8 from both sides to get x squared plus 2x minus 8 is less than 0. Now I can factor this quadratic equation, this quadratic inequality, x squared plus 2x minus 8, by finding factors of negative 8 that add to 2. Right, so if you're kind of confused on how to factor, I do have a video on factoring quadratics, so I would recommend checking that out. This is kind of a prerequisite skill for this topic here, so I'm going to kind of speed through the factoring, but like I said, if you're confused on it, please go back and see my video on factoring. So I want factors of negative 8 that add to 2. How about, let's pick negative 2 and 4, right? Negative 2 times 4 is 8, and negative 2 plus 4, or in other words, 4 minus 2 is 2. So I'll use these factors. So I can split this up into x minus 2 times x plus 4 is less than 0. Okay, so let's kind of think for a second. So the inequality that I'm looking at is asking for values of x so that this product here on the left-hand side is less than 0. So I'm looking for values, so we're looking for x that make x minus 2 times x minus 4, right, this left-hand side, plus 4, this left-hand side, less than 0. What does it mean if a number is less than 0? Well, that means it's negative. So I'm trying to find when this is negative, right? So the way I go about this is by making what I call a sign chart. So basically I draw a number line here, and I need to find the zeros of this left-hand side. The reason I do that is because I note that for a quadratic equation, if it touches 0, right, okay, so I'll draw a picture here. So for example, this is what, let's say this is my quadratic. When it touches 0, on either side of it being 0, it has to be either positive or negative, right? So if I can find my zeros, I know in the intervals in between, my function is either, my quadratic here is either positive or it's negative. So finding zeros of this, zeros of x minus 2, x plus 4, the zeros of that are x equals, well, we can set them separately equal to 0, is going to be x minus 2 equals 0 and plus 4 equals 0. So x equals positive 2 and x equals negative 4. Okay, and now I'm going to plot these on my sign chart here. So this is a number line. So we'll say x equals 2 is here, and we'll say x equals negative 4 is somewhere down here. And we know that 0 is going to be somewhere here. So the question is, should I even consider the points where it's 0? Well, not really, right? Because if I'm looking for the region that this inequality corresponds to, we're talking about less than 0, not equal to 0, not less than or equal to 0, but less than 0. So we don't include these points when we're talking about our intervals, and we'll look at that a little bit more here in a second. But what I'm going to do is I'm going to test in between each of these, I'm I'm going to pick an easy value that I can plug in to this left-hand side here. So in between -4 and 0, it's really easy for me to pick 0 as a test value. After 2, I can pick 3 as a test value. And before -4, I can pick -5 as a test value. And what I'm going to do is I'm going to use these test values and plug them into this left-hand side here and see if what I get is positive or if what I get is negative, right? So we're going to write here the sign, we're looking for the sign of x minus 2 times x plus 4, okay? And remember that my sign won't change, and my sign of my function rather, or my sign of my product here won't change unless it touches 0. So it has to be negative and then 0 and then positive, or positive then negative then 0. So in other words, sign only changes when the function is 0 or when my product is 0. So all of this to say, I'm just going to plug in these test values to the left-hand side. So plugging in -5 here, -5 minus 2 times -5 plus 4. So it doesn't actually matter what this evaluates to because we're only looking for the sign. So -5 minus 2 will give me a negative number. -5 plus 4 will give me -1, so it'll also give me a negative number. A negative times a negative is a positive. So before -4, we're positive. Okay? Now plugging in 0, I have 0 minus 2 times 0 plus 4. -2 is a negative number, positive 4 is a positive number, so I have a negative times a positive, which is just going to give me a negative. So in between -4 and 2, I have a negative, and then if I plug in 3, I have 3 minus 2 times 3 plus 4. So 3 minus 2 is positive 1, so it'll give me a positive number. 3 plus 4 is also positive, so a positive times a positive, which is a positive. Okay, so I figured out that this left-hand side here is positive before -4 and after 2, and negative between -4 and 2, right? And my goal is to find all of the x values, that is all the points on this line, where this is negative, right? Less than 0. Less than 0 means negative. So the x values that make it negative, or the x values that satisfy this inequality, we'll write x minus 2 times x plus 4 is less than 0 when I have x is strictly greater than -4 and x is strictly less than 2, right? That's this region here where this guy is negative. This left-hand side here is negative. So our solution, if we want to write it in interval notation, is our solution is the open interval from -4 to 2. Why is it open? Well, at -4 and 2, we said earlier that this product is 0. And you can verify this because if I plug in -2 here, I get 0. And if I plug in -4 here, sorry, +2 here, I get 0. If I plug in -4 here, I get 0. So my product will be 0. But we don't care if it's 0. We only care when it's negative. So we don't include the parts where it's 0. Or in other words, we don't include -4 and 2. Okay? So let's move on to this next one here. I've got x cubed plus 6x squared is greater than or equal to -x. Okay, so again, I want to rewrite this in a form that I can factor it. My goal is to factor so that I can apply this sign chart technique that I've been using here. That makes it easier to kind of figure out what I'm looking for. So let's put this in a form that I can factor by adding x to both sides. So 5x cubed plus 6x squared plus x is greater than or equal to 0. Okay. Now my goal is to factor completely. I want to factor this as much as I can. The first thing I notice is that each of these terms shares an x, so I can factor out an x here. And I'll have x times 5x squared plus 6x plus 1 is greater than or equal to 0. Okay. Now, I can factor in here, in this little parentheses part, I have a quadratic that I can factor. And I'm looking for factors of 5 times 1 that add to 6. Another way you may see this written is I need factors of 5 that add to 6. Or no, it's like this. Target product, target sum. Factors of 5. No, I had it right the first time. Factors of 5 that add to 6. So I need... So why not take 5 and 1, right? Because 5 times 1 is 5, and 5 plus 1 is 6. Now, recall, a is not 1, so I have to factor this by grouping. So I do this a little bit differently. I have 5x squared. I'll split this 6x up into 5x plus 1x plus 1, and that's all greater than or equal to 0. Again, if this factoring is confusing to you or you're not sure what's going on here, refer back to my factoring video. Okay. And next I can factor this from this left part here. I can factor out a 5x. I have 5x times x plus 1. And then on this other side I have 1 times x plus 1. So factoring by grouping, this gives me x times 5x plus 1 times x plus 1. It's greater than or equal to 0. Again, if you're confused on that, go back and watch my video on factoring quadratics. This is specifically a case where a is not 1. Okay, so I want you to note kind of the structure of what we're doing here, what our steps are, in other words. So our first step is to rewrite so we can factor. Our second step is to factor completely. And this is in general for, I guess we could call them polynomial or quadratic inequalities. We want to rewrite so we can factor, then we want to factor completely. Next, what we want to do is find zeros of the left-hand side. So we just take what we have here on the left-hand side and we set it equal to 0. Notice we did the same thing on the last problem. So we're going to take x times 5x plus 1 times x plus 1 equal to 0. Now I know that I can just, by the zero product property, set each of these separately equal to 0. So x is equal to 0, 5x plus 1 is equal to 0, and then x plus 1 is equal to 0. So subtracting 1 from both sides, 5x here is 5x is negative 1, divide both sides by 5, and I get x is negative 1/5. And then I can subtract 1 from both sides of this equation to get that x is equal to minus 1. Okay? So these are my 3 zeros. Okay? So I'm going to take my zeros and plot them on a sign chart. So my next step is to make a sign chart. Fourth step is to make a sign chart and plot zeros that we found. Now we're going to note, if we're looking at strictly less than or strictly greater than, we don't include zeros. We would write them as an open dot, right, an open point. So like notice here, we wrote these as an open point because we just had strictly less than. We wrote our zeros as open points, and we didn't include them in our interval. If we have less than or equal to or greater than or equal to, then we do include zeros, and we draw them as a solid dot. So in this case, we have greater than or equal to, so we do include our zeros. So I'll plot my zeros here. X is equal to 0, we'll put here. And x is equal to negative, maybe we'll move 0 over here. X is equal to negative 1/5 might be somewhere here, and x is equal to negative 1 will be here. Okay, and we're looking for, in this problem specifically, we're trying to find when this left-hand side here is greater than or equal to 0. So we want to find when this left-hand side is 0 or positive, right? Because greater than 0 means positive. So we're going to compute the sign of this. So what we're doing here is we're looking at the sign of x times 5x plus 1 times x plus 1. And we gotta pick some test values between our zeros now. So I guess our fifth step will be to pick test values. So let's pick some easy test values. An easy one to the right of 0 will be 1. An easy one between 0 and 1/5, maybe we say 1/6, negative 1/6. And between 1/5 and 1, we can pick easily at negative 1/2. And then before negative 1, we can easily pick negative 2. Okay. So I gotta test all of these test values in my left-hand side here. Remember this bit here. And we want to see if they come out to being positive or being negative. So plugging in negative 2. So we're going to pick test values and plug in to the left-hand side. So plugging in negative 2, I have negative 2 times 5 times negative 2 plus 1 times negative 2 plus 1. Again, we don't actually care what it evaluates out to because we only care about signs. We're only looking at if it's positive or negative between these intervals here. So negative 2 gives me a negative, so I have a negative outside. So negative 2 times 5 is going to give me negative 10 plus 1 is still going to be negative. And then negative 2 plus 1 is negative 1, so it's also a negative. Two negatives make a positive, and then I have that times a negative. So overall I have a negative. So on this side, my product here is negative. My left-hand side is negative. Testing 1/2, I have negative 1/2 times 5 times negative 1/2 plus 1, and then I have minus 1/2 plus 1. Okay, so obviously this negative 1/2 on the outside will give me a negative. 5 times negative 1/2 plus 1. So 5 times 1/2. Let me give you some reasoning here. I don't have to actually compute it out. 1/2 of 5 is greater than 1/2 of 4, and 1/2 of 4 is 2. So I have something that's less than negative 4 over 2 plus 1. Let me restate that. So for this middle one, we're just going to use a little bit of logic to figure out if this is positive or negative. So we know that so we know that negative 5 over 2 is going to be less than negative 4 over 2. So what I'm saying is we have negative 5 over 2 is less than, not less than or equal to, but less than negative 4 over 2. And negative 4 over 2 is negative 2. So I have something less than negative 2 plus 1, which is negative 1. So this is also going to be negative. And then this negative 1/2 plus 1 is going to be positive 1/2, so this is a positive. Two negatives will cancel out and make a positive, so I have positive times a positive, and so I overall with a positive. So in this interval will be positive. Okay. Plugging in 1/6, I have negative 1/6, 5 times negative 1/6 plus 1, and then negative 1/6 plus 1. Okay. This negative 1/6 outside gives me a negative. So negative 5 over 6. 5 over 6 is less than 1, right? Because 6 over 6 is 1, so 5 over 6 is less than 1. So negative 5 over 6 is greater than negative 1. It's closer to 0 than negative 1. So that means I'm subtracting something less than 1 from 1, which will give me something positive. So this middle thing is positive. And then 1 minus a sixth is going to be 5/6, so that's also positive. Positive times a positive is a positive, so I have negative times a positive, and that leaves me overall with a negative. So in this interval, I have a negative. Now, plugging in 1 here, do it down here, I have 1 times 5 times 1 plus 1 times 1 plus 1. So clearly 1 is positive, 5 times 1 plus 1 is going to be positive, and 1 plus 1 is also going to be positive. So this whole thing will be positive. Okay. Great. So let's remember what we were doing before we got kind of stuck in this rabbit hole. So we found our signs of our intervals. So between, negative infinity, -1, -1, -5, -1/5, -1/5, 0, and so on. And remember, we were looking for when this product, when our sign here, that's what we were solving for, is 0 or positive. So let's highlight the intervals that we care about. We know that from -1 to -1/5, we are 0 or positive. And we know from 0 onwards, we are 0 or positive. So the intervals that are going to make up our solution, solution is the interval from the closed interval from -1 to -1/5 union, that is along with the interval from 0 to infinity. Why are our intervals closed? Oh, this should be an open parentheses. Why do we include our zeros here? We include our zeros here because remember we were looking for when we were 0 or positive. Our zeros are zeros, right? Clearly. So we include them in this case. Okay? Okay. So that does it for quadratic and some other kind of polynomial inequalities that you might see.